Good evening, class. This is our final project, the Catapult.
Okay, we are Carlos Rodriguez, Romina Caloyan, Aldo Bautista, Luis Carlos Vega, and me, Giovanni Norman.
Description.
The catapult is an antique long-range weapon used in the medieval times. It was used to launch from boulders to explosives to inflict damage to the opposing side. The catapult will be executing a variety of different launches and recorded with the purpose of saying how the distance varied. Half of the travel will be with the handle extending in 70 degrees and the other half in 140 degrees. This way we can identify the most efficient use of the catapult. And this is the model we use for our project.
So the objectives are the main priority during the construction was to make the catapult as sturdy as possible with the purpose of minimizing the variation in the launches, being distance and direction. In order to do this, we measured different measurements to determine the most accurate outcome and landed most in the box. And another factor we considered was the person that operated the catapult launching, therefore changing the outcomes.
Okay, the CPOP. I'm going to explain the CPOP. It has 3 steps: supplier, process, and customer. The supplier is thin wooden board, wooden beam, wooden stick foundation, half spare cup, rubber band, glue, screwdriver, salt, dry, and some pepper. And the process is constant performance, quality materials, made to last semi-accurate distance and direction, antique weapons, and used for centuries. And the customer is the teacher, Martin.
So the CTQ was this one, and the action was to reduce deviation between catapult shots to 0.9 when the first week of December, that is when our project was due, and who? By our team members.
Okay, the flow chart. The first point is design catapult, purchase materials, cut pieces, put pieces together, obtain finished product, place catapult to choose place to perform, place tape on the catapult to stick it to the ground, place the correct set up for each treatment, designate operator in place to start the shots, measure and record data, and continue with the following. And the EPO is like the same of the CPOP, thin wood, wooden beam, wooden stick, and the same process.
Materials. For a base, we sawed off a piece of wooden board and then glued on 2 foundation sticks to hold the horizontal sticks. Then we used the rubber bands and half a sphere cup in order to put the rock in and then launch it. After that, the wooden beam was drilled onto the wooden stick. And all of these items were used from recycled scrap.
Well, talking about the fishbone, we have a lot of factors that can help our process to decrease the deviation. But what can we conclude of this root cause diagram? That our root cause in this case is the shooting distance.
So the SNIA was the process functions, and we mentioned several process functions and their potential failures, which is selection of material to build catapult, and it was that we could make a poor quality catapult. Process of making catapult, it is incorrectly built. Setup for catapult, poor quality setup. Shots, each operator involves a different type of shot. Capturing distance data, distance is hard to register. Purchasing material without making the design, we buy the wrong material. Not paying attention to detail, and doing quick shots without preciseness, not paying attention to the time when the ball falls down. And our constants were the height, catapult position, and release timeout. They were all quantitative, and the ranges varied.
Well, as Romina said, there are many factors that can help our catapult that decreases the deviation. Mentioning some factors, we have the operator, shot angle, type of rubber band, excuse me, and type of ball. On the other hand, we have the factors that can affect our analysis, or in this case, increasing the deviation. Talking about the Taguchi, the analysis we chose to use the Taguchi technique, for it allows us to use different range of degrees on the lever. In this case, we use 4 factors with 2 levels each and 12 varied methods, as you can see on the chart.
The experiment execution. The design was to use 12 trials, and from these 12 trials, there was 4 main factors, which was the lever angle, the rubber band type, the operator, and the ball type. And as you can see, these are the first launches with the ping pong ball. Right here was the foam ball, back again with the ping pong ball, and the foam ball. And the first 2 ping pong launches were by me, and the other 2 were from Carlos, or Luis Carlos. And then the second foam shot was also by me, Carlos, and so on.
We used 2 types of ball, which were the ping pong and the foam ball, and the operators, as my partner Aldo mentioned, was him and Luis Carlos.
We have 2 types of elastic band. The first one is rubber band, and the level 2 is rubber band. 2 types of angles. 70 and 100.
Viability analysis. First, our team initiated by looking into unused material that was just going to be waste. And in the process, we found, as previously mentioned, the thin wooden board, the wooden beam, some 2 wooden sticks, 2 wooden blocks to use as the foundation, half a sphere cup to hold the material, and 4 rubber bands, two for each trial. And after that, we built the catapults and recorded the process. After that, we lent out the catapults for our other team, or classmates, and their teams, in order for them to do the same. And this right here is our evidence and how our trials went.
There's a measuring.
Conclusion. We used 4 different factors to vary the shots after the technique calibration was followed by the recording of data. All 4 factors displayed a plethora of changes being distance and direction. As previously mentioned, these were the 4 factors: lever, rubber bands, operator, and ball type. The best result was the following. The angle of the lever in which the catapult was pulled was 70 degrees, with the best operator being my partner Luis Carlos. The best elastic band was the level 1, the first one, and the best type of ball was the foam ball.
So with all the shots we made, we can see our graphs, and we can see that on these graphs we show the principal effects for the standard deviation with the different type of charts.
So in order to reduce the deviation, we have to choose the lowest point of each line. In angle, we choose the 70 degrees. In type of we choose the foam ball, rubber band 1 or single, and operator my partner Luis Carlos.
Here's a matrix we use to do the Taguchi method, and with a total of 12 different trials. And over here we have the recreation graphs, and we can see all of the shots we made and how they varied according to the different type of shots made. And here's the same, but with standard deviation.
Okay, and as for these graphs, this is how the shots varied in the standard deviation. As you can see, the dots are a bit more dispersed in comparison to the mean, and also followed by the adjustments and the histogram and the order of the trials. And as Romina mentioned, this right here is the variations between the type of ball, angle, type of rubber band, and operator. As you can see, the two methods that varied the most were the angles and the operators. For their variation was the longest. As you can see, the closest to 0 would be 70, being the best option. And for the operator, also the one closest to 0 was Luis Carlos, being the best option. And this is the sound.
This is for the signal noise.
Signal noise, yes. And as you can see, this varies a little bit less than the standard deviation, though the order did also vary very much in comparison, and so were the adjustments. And as you can see here in the -2, there was also no residue. And this is the same, signal noise for the means. For right here, it also varies more than for the standard deviation, but in this point it gets closer to 70, so the angle of 70 degrees is still the most viable option. And in this case, the type of ball and the type of rubber band were a bit more important to the operators, for their variation was larger. And as you can see, the foam ball was the best option, and so was the level 1 use of rubber bands as well. So always the same method, or the same best option.
And this is some of the evidence of the best shots considering the best factors for decreasing the deviation.
So thank you for watching. We'll see you next semester.